After being stuck at our houses for the last month and a half, let's talk about a whole nother planet. Almost everybody knows about the Mars probes, and the Spirit and Opportunity rovers. But today I'll be talking to you about the Magellan radar mapping mission to Venus. Now, I'm in my second semester of geology, so I have a little bit of a background in studying the basic study of our planet. So, why did we send a probe to Venus? NASA sent a probe to study Venus for the same reason we study any other planet, for the sake of scientific discovery, or sometimes just to beat the Soviets to it. According to the book, The Face of Venus, the mission was launched by the Space Shuttle Atlantis on March 4th, 1989, and it wasn't terminated until the October of 1994. And this mission was the first deep space probe launched by a space shuttle, and the first spacecraft to map the entire surface of Venus. The spacecraft used a new technology called synthetic aperture radar, or SAR, to provide a better resolution than the mapping mission to Mars. The basic spacecraft was actually assembled with spare parts left over from prior missions, such as Galileo, Voyager, Ulysses, and Mariner 9. Now, after 3 course corrections on various states, the probe arrived at Venus on August 10th, 1990. 6 days after entering orbit, the spacecraft suffered a communications outage that lasted 15 hours. And then 5 days later, it suffered another one. So the ground crew after that set up a preventative software and it didn't happen again. The probe started sending SA radar images back to Earth on September 15th, 1990, 36 days after entering orbit. So what information did the probe acquire? According to NASA's website, the Magellan probe completed 4,225 usable SAR imaging near-polar elliptical orbits around Venus. Each orbit covered an area of about 20 kilometers by 17,000 kilometers at a resolution of about 75 meters per pixel. And each strip was essentially compiled into a larger images in a very complex way. The probe's scientific mission was to study landforms and tectonics, impact processes, erosion, deposition, chemical processes, and model the interior of Venus. It's a quote from NASA. The spacecraft actually returned 1,200 gigabits of data back to Earth, which is a lot considering the planetary missions up to that point only delivered 900 gigabits of data combined. Magellan completed its first 243-day cycle, or 1 day on Venus, on May 15, 1991, providing clear views of 83.7% of the surface. And the mission exceeded its original goals after its second cycle of the planet, completed on January 15, 1992. And the Magellan spacecraft actually completed a total of 6 cycles around the planet and mapped 98% of the planet's surface. Magellan found that even though Venus is very close in size to Earth, the geology is even more considerably different. One of the main reasons for this is the extreme heat of about 850 to 900 degrees Fahrenheit. The probe also discovered that about 85% of the surface is covered in volcanic flows. So even with that really high atmospheric pressure of about 92 bar, the lack of water slows erosion considerably. And closer to the end of the mission, a technique called aerobraking was used to get the spacecraft into the Venusian atmosphere. Aerobraking is quite literally using air resistance to slow down any aircraft, in this instance a spacecraft. After being lowered into the atmosphere, the spacecraft would conduct what NASA called the windmill experiment, where it would orient the solar panels on the spacecraft perpendicular to the orbital path, and then it activated the thrusters so it would counter the spin. At that point, it could collect data on the atmosphere. So, what have we learned? The Magellan mission, this mission, being not quite as well known as some of the Mars missions, is just as important in the discoveries made. The Magellan mission, being the first deep space probe launched via space shuttle, paved the way for future missions like those famous ones to Mars, for example. And knowing what we know now can and has benefited missions to Venus after this one. Also, discoveries about Venus can tell us things about Earth, like perhaps what the Earth might even look like in the future. Now, the Magellan mission to Venus was and is important and is interesting in a number of ways. This mission to the second planet from the Sun was but a single step in uncovering the mysteries of Venus. Now, we have gone over the overview as well as more details about the mission, and the planet continues to intrigue both astronomers and researchers alike. Now, living on a planet like Earth with liquid water is very nice. After all, a life without Coca-Cola would not be one worth living. Thank you very much.